Hi everyone. Today we're going to be solving the HMMT 2019 Algebra and Number Theory problems. So the HMMT is the Harvard MIT Math Tournament. So we're going to be solving each problem one by one. So let's start with the first problem. So the first problem statement is compute the sum of all positive integers n for which the expression n plus 7 over the square root of n minus 1 is an integer. Okay, so let's just rewrite that. N plus 7 over the square root of n minus 1. Okay, so we want to see how we want to find out all the possibilities of n, which will give this expression a positive integer. So that means we want this to be a positive integer, so it's a z plus. So that means that the top and the bottom, just for pure measure and like to make it easier on ourselves, they both have to be also positive integers. So, well, this means that the n minus 1, the square root of n minus 1 has to be an integer. So that means that n minus 1 should be equal to k. So that means that n is equal to k squared plus 1. So that is what we're going to use to find this answer. But we have this linear expression, and we want to break this up into just one expression plus another expression, which is just an integer m over this expression, the square root of n minus 1, and preferably we want the same exact function so that we don't have to compute anything else. It'll just be, we want to find some expression that is equal to this. So let's venture out in the search of such an expression. Well, we want to find how to get n minus 1 separately. So n plus 7 is just equal to the expression n minus 1 plus 8. So all over the square root of n minus 1, and then we can divide this into two parts. We have the fraction n minus 1, and let's write it a little differently. N minus 1 to the first power over n minus 1 to the 1/2 power, because that's a square root, right? And then we add 8 over the square root of n minus 1, which is exactly how we want it to be. So, and if we use the power rule of exponents, 1 minus 1/2, that's the power. So then we're just left with the square root of n minus 1 plus 8 over the square root of n minus 1. So this has to just be an integer. It doesn't have to be a singular value. It just has to be an integer. So that now we know that n minus 1 must be divisible by 8. So that means that this has n minus 1 can either be equal to 1, 2, 4, or 8, because those are the factors of 8. So remember how we said that let's just let this n minus 1 equal some value k, which are these expressions, right? So that means that k is equal to 1, 2, 4, or 8. But n is equal to k squared plus 1, because we have to just get rid of this radical, so that we have to square it, and then we have to add a 1 to both sides to get rid of this 1. So we just have to plug in these values, 1, 2, 4, and 8, into this equation. And then we get our answers are n is equal to 2, 5, 17, and 65. These are the 4 different values of n. But we're not done yet. Remember how the question said we have to compute the sum of all these positive integers. So we're almost done. So we just have to find the sum of n, and that's equal to 2 plus 5 plus 17 plus 65, which is equal to 24 plus 65, which is equal to 89. So therefore, the answer to this question is simply 89. So that's the end of the problem. I hope you guys enjoyed it, and thank you and have a nice day.